So I'm going to continue to record the class because it's important. Those who miss, they can technically, um, yeah, they can understand. And those who registered late, enrolled late, I will double check with the coordinator here, and let's see how we can support you or allow you to do your complete your work as well, and your attendance, if we can change that or not. But in the meantime, while you have just enrolled, try to cover your missed content that you did not get a chance to cover. So um, as we are just going through the lecture one topic, so that's good that you can revise. And if you have any questions, let me know. Okay. So in the first lecture, we looked at the definitions of data analysis. Okay. What is meant by data analytics? How do you look at the data? You try to ask certain questions to that data set, and then you have to make certain changes in the data set and then get the answers. Okay. So it's a complete process. It's a scientific process where we change the data and we try to we make some changes, not in terms of content, but we add it in terms of if there is a missing value, we get rid of those data values, or if there is an attribute that is not necessary for the purpose of your analysis, you can simply remove that. For example, any personal detail that you might not be interested in, you can remove that from the data set, and then you can continue with your analytics. So the objective of analysis is to help you in better decision making for future. Okay, so that you can perform better decision making. We looked at strategic, tactical, and operational decisions. So you should be across this one as well. And the types of analytics, we discussed descriptive, where you just describe the data set. Okay, the example we revised at the start of the class today as well. It's from your tutorial. So the first question that you can, by looking at the data set in the Excel or CSV format, you should be able to tell how many records are there and how many attributes they are used to define that data set. Okay, and what is the purpose of each one of them? What question can we ask by looking at this particular feature or this particular attribute? So you need to understand um, what is the objective of each one of those attributes. Now, real time data is the one that is coming in and being collected actively while performing those management tasks or while executing those business processes. Okay, for example, if I have to look at the data set for a chain of stores in Sydney, any commercial chain of stores that has got the location, the store locations at different suburbs within Sydney, then the daily transactions that are taking place at each chain of store would represent the real time transactions or real time data sets. Okay, so the transaction oriented or the routine tasks that are being done. So how many insights do you get in 1 minute? For example, every minute your chain of stores might be having multiple transactions being done at different locations, so you can get in those transactions or the data coming along in real time. Okay, diagnostic would be that you have to figure out that we collected the data set from Sydney, let's say from the metro area, plus one of them is from the Newcastle side, let's say, and another one is from the south of Sydney. And we try to determine that why are we getting a really low number of data sets from the Sydney metro data side, although we expect metro to be really busy. Okay, so we are trying to diagnose that what could go wrong. Either data is not coming in from all locations or we are missing certain aspects of the data set. Okay, so that's diagnostic. And then we try to determine, okay, for example, you have looking at a brand, for example, target, they are trying to sell certain winter clothings. So they need to determine what happened to the white jackets. Why white jackets? The number of white jackets being sold is low. Okay. So they try to diagnose that what happened, that particular white jacket. Did that have a flaw, or the size was really not good? That individuals they tried, they could not fit in, or what happened exactly? So you're trying to diagnose by looking at the partially operational data set. So things are being done now, and then you're trying to figure out, okay, what happened here and how did uh, something went wrong that we are getting the data set from a different perspective. Okay. Then predictive will help us to predict for future. Okay. So predictive will help us to determine um, that what went wrong and how can we improve on that particular aspect. Okay, so that would be the predictive thing that needs to be covered. Let me share this screen so that your slides are visible here on this screen as well. Then we have prescriptive. So we predict, for example, since this winter, the number of the those jackets or the trousers that are coming in for the winters, their count is higher. We predict that yes, at the start of or at the end of June or start of July, we will be getting a higher. We will be requiring a large bulk of those items so that we can execute our business processes in a better way. Okay, and prescriptive would be that yes, it has been happening over a period of time that we end up getting short in these particular items over a period of time. So let's continue to supply and look at the customer feedback and make sure that they get updated always. For the purpose of this course, you will end up doing descriptive, partially diagnostic, and since we are not getting the data directly from businesses. Rather, we are relying on data from a data source that's called Kaggle. Okay, so I will talk about that a bit later. So the CSV file or the data file is already set up, as you can see on the other screen, the airline data set, for example, that is coming in from Kaggle. So it is from real-time business operation, but it is converted in a format that we can perform our analysis in a fairly better way. So for the purpose of this course, you will end up doing descriptive plus diagnostic and predictive. Okay, so predictive would be one that we really want to do, but you might end up only few students, they might have the prescriptive dimension done as well, but primarily descriptive, diagnostic, and predictive. These are the three different analytics that we look at. Okay, we discussed different examples of data queries from the airline data set, okay, in the beginning of the class. So for predictive, we require data set to be really large, or the big data set. That's what we are going to cover in topic 2. That what are the requirements for that big data where we can perform the prediction, we can conduct those predictive analytics, and the operations or the steps for the predictive analytics might include linear regression, time series analysis, or any of the data mining analysis. So we are going to rely on models that are part of Rapid Miner that we will study a bit later. So we will apply those techniques onto the data sets to determine or to find our answers from the data set. So and then prescriptive, obviously, just like a doctor writes a prescription. So they are going to provide you with the rule-based solutions. That these are the rules, these are the prescriptions that we can use to fix problems in the previous data set. Portfolio models in the finance optimize investment returns while managing risk. Retail price markdown models optimize revenue by determining optimal discount levels and timings. So those optimization models, they could also be done as part of your assessment 3 and 4, or the assessment where you are doing your presentation plus the report. Okay, but we will talk about in terms of that particular tool. How are you going to use that? Yes, is it MBA 909? Yeah. Data analytics. Is this your first class? If you please have a seat. Yeah. Let's start with the big data now. So this was all about the topic 1 revision plus some aspects that we could not discuss in the week 1. This is your week 2 topic. Did you get a chance to look at the recorded class for the topic 1? Okay, so make sure once you log in through, have you got your laptops with you? So once you sign in through Teams, you do see a link of the previous week's recording there. So if you cannot, let me know. Otherwise, yeah, I should be able to help you how to look at that recorded session. Yeah. So for the purpose of predictive analytics, you have to rely on the big data set. Okay. Now, our first question is now, what is big data and what makes data big data? Have you heard about this term big data on top of your head somewhere? How do you define? Yes, online students. Collection of data sets. Yeah, that's correct. What else? Yes, online students. You can either type in the chat window or you can unmute yourself and yeah. What do you think is a big data?
Massive and complex database. That's all I can say from this big data.
Yeah, it is complex. Okay. Um, so as the term suggests, big. So how big does the data set have to be? Okay. So for example, if I ask you, I have a class of, let's say, 37 students for MBA 909. I know their names, their IDs, and their email addresses, and I've got those collected in the form of an Excel sheet. So is this data big data? So by definition, it is data whose scale, diversity, and complexity, they require new architectures. They require intense techniques. So you require certain techniques. Algorithms can be implemented on top of them. And you can apply the analytical methods. You can use those analytical methods to manage and extract the findings or knowledge from the data set. Okay. So do you think that would be classified as big data? Since it is limited, okay, it has limited count, 37 students enrolled in a course and just their first name, last name, and there is no other information. What about their grades? What about their satisfaction levels? What about their performance? What about their visa status? What about their enrollment? How many units did they cover beforehand? So there are lots of other things that this attendance file does not talk about. Okay, so we cannot classify any file to be a big data file. For any file to be big data, we need to have certain aspects that need to be answered. There are requirements. Okay, so they are called 3 Ds or 3 main requirements. Then we have a fourth one as well that we will discuss. The first one is the volume of data. Okay, so you can see the volume. Data must have a volume. It has to be greater than a specific number depending on the number of transactions. For example, if I look at airline data set and every flight can have, let's say, 300 to 500 passengers in one flight, let's say, then by defining the data set to be a big data, we are looking at least 1,000 such flights with certain number of passengers. And then we should have at least 10 to 15 different attributes that we are looking at. It's not only their first name, last name of the passenger. We should have more details about those passengers, plus about the flight. Okay, so the number of attributes that we have and the number of records that we have, like volume should be really big. So that's the count of the records that tells the volume. So if you go back to the airline data set, how many records did we have? 25,000 plus, right? So there is a volume of the data over there. What about the variety of types of data? Variety means how many columns did we get? We had data where we have passenger names, then the class in which they are traveling, age, their gender, plus whether they are satisfied or not satisfied, and then whether they are satisfied or not satisfied across 10 different parameters. Was it the flights being on time, or was it the leg space in the flight? Okay, so there were 10 different such aspects were covered. So there is a variety of the types of data that are discussed in that particular file. Okay, plus the velocity at which the data is generated. So it is not coming in from just one flight. Rather, we are looking at 5, 10, 15 multiple different flights, and then we are trying to incorporate that velocity. Okay. So for the data set about MBA 909 in the term 2 2026 that is being offered here in Sydney will not be classified as big data. Rather, we can say that, okay, for MBA 909, for the past 5 years, number of students that have studied. Okay, so we can collect that data for the past 5 years, and we can see that how many different instructors they taught this course. Okay, and then what was the satisfaction level and what was the success level, whether students passed that course or they could not go through the course successfully. So that would be different dimensions based on which we can look at the large volume of data for the past 5 years. There would be technically 5,000 plus students in that for that particular unit that they covered in different velocity means in different time frames. So term one of 2020, term one of 2021, 2022, 3, 4, 5. Okay, so those past 5 years, we will look at a velocity that is generated across period of time. Okay, so this velocity may be defined distributed across a period of time, or it may be defined by a distribution across different locations. Okay, so students at KOI in Sydney campus, students at KOI in a Newcastle campus, plus hybrid students or those who attended face to face. Okay, so we have got lots of velocity, lots of descriptions that differentiate certain sets of data within that same particular file. Okay, so that fulfills the requirement of the big data. Okay, so the first requirement is volume. Volume can be determined by number of records. Okay, how many are we getting? Variety means how many different attributes they are allowed to be defined. Okay, or is it different locations the data is coming in from, or is it different aspects that we are trying to cover? Velocity would be either based on time or based on location or any other dimension that you may think of. Even within time, is it monthly? Is it trimester, like 3 trimesters in a year? Or is it every month or weekly data? So what is the velocity of data being updated? And another V that we get is, so I think volume, the records, right? We discussed that. Velocity is how effectively are we getting it moved across different locations or across different time zones. Okay? Variety is how many different types of attributes are we looking at. Then there is a other element that is called the fourth V of big data. Okay, so even if you put that in Google or ask AI, you can get the answer. Like, what are how do we define big data? How do I define big data? It will tell you the first three main requirements. Okay, then if you ask the four V's of big data, it will give you this, because this is determined by research. And veracity is kind of uncertainty, kind of incompleteness that may exist, that may prevail. Okay. So, for example, we do have data set for the past 5 years, but in the year 2020, MBA 909 had a different content. Okay. So we cannot exactly match them, but uh, some of those dots, they are not clear. They are not like 100% aligning with, like, all attributes are not answered for the first year data set, because it was offered in the same unit had a different content. And let's say, for example, we are having four assessments this time. We are having three assessments this time, but until year 2025, we had four assessments. Okay. And in the year 2020, we used to have a final exam as well. Okay. So that attribute will not match. The final exam attribute in the year 2020 will not be found in the as a final exam attribute for MBA 909 for 2026 students, because there is no final exam now. Okay? There will be few dots that are not connected, while the other dots, they are very clear. You can see they are sharp and clear, while some of them are blurred. But instead of putting those blurred dots into the bin, we are still keeping that whether they were satisfied or not. Okay. Another example that I usually provide to the students is that of the grocery store data set, okay, across different locations. If you take the example of Woolworth or Coles, you can well imagine how many outlets are there. So for certain outlets, transactions are done, but somebody came back and they returned the items within that time frame and it is completely deleted. But somehow it exists within the system. So those updated transactions, they are there, but they do not exist. So those are the blur dots. So there is a veracity within the data set that something went wrong, but we don't know the details of what exactly went wrong. Okay. So instead of losing that, we do get some ambiguity, we do get some inconsistency. Okay. So the first step that you do as part of the analytics would be to get rid of those such kind of observations, so that we have clear, concise, clear dots. They need to be picked up. But again, this is a decision. If we don't have any data, if I pick up, if there are only two dots that are clear, and if I just pick up them, the definitions of the big data, they are getting affected, then we cannot ignore them. Okay, so we will try to determine what can be extracted from those blur dots. Was it the time of the transaction, or we will still try to keep them in. Okay, so these are four different definition, four different aspects that must satisfy for any data file to be classified as big data file. Okay. And the reason why we are studying this is because for the purpose of your first assignment, you have to pick up, or you have to select a data set that fulfills those requirements somehow. Not exactly, obviously, you cannot align in 100%, and you won't be able to process that as well. But you need to make sure that you are working in alignment with the requirements for big data. Okay. Now, what are the characteristics? Big data could be structured, semi structured, or unstructured. When we say data is structured, what does it mean? And when we say data is unstructured, what does it refer to? Any idea? Yes, online students. Structured versus unstructured. You can put that in AI. Type it in. and try to determine.
Structured, ma'am. When we generally first time record our transactions, it's usually in the unstructured, and when we finally put it into the rows and columns, it's becomes the structured data.
Okay, so the data that is coming along in the form of rows that has rows and columns, it is
Yeah.
definitely structured. Okay. So what about the unstructured? Would be the example for unstructured. Yes, you are right. If we do not store it in the database, and if we say that, okay, somebody has sold two toothbrushes and one toothpaste somewhere, we have no structure. We know that, okay, it is sold somewhere downstairs in one of the grocery stores. Uh, but how did it happen? We don't know. Okay.
Yeah.
Uh, but the clear example of structured versus unstructured would be, for example, when you walked inside this building, lots of those security cameras, they recorded your existence. Okay, so a video recording is done, right? So, or audio recording, for example, of your class is being captured, audio as well as video. So this data is some form of unstructured, although if we need to know what is done in this video, we will have to double click on MBA. We know that it is MBA 909 recording. Why? Because if we add that tag, if we add that name and we keep storing those videos with MBA 909, yes, this video contains MBA 909 lecture recording. But if I go on a holiday trip and I create certain recordings of my holiday, I would keep them as a video on the same drive or on my personal computer drive, while I have my uh, recorded lectures stored in the same drive as well. How do I differentiate? Okay, so I try to create that structure by creating a holiday folder and then creating a professional work folder where we have MBA 909 classes stored. Okay, so we try to add structure onto that unstructured data by placing them in different folders, by naming them differently. But if you lose those names, if you just extract all of the videos from your hard drive, you won't be able to tell which trip are you talking about, okay, or which particular location are you looking at, the photos that you capture on your mobile, for example. You won't be able to relate until you go and find the dates or timings, or by looking at those pictures uh, you can get to know full story. But until there is just the file name or date, you might not be able to tell the full story. Okay, so the images, audio, video, these forms are called the unstructured file, while the structured file would be, for example, your airline data set where we had ID and then we have certain attributes. Okay, your attendance file, for example, we have student IDs, first name, last name, and the attendance record for each week. Okay, so that's called the structured data. Now, semi-structured comes along, or quasi-structured comes along. Even the data, the transactional data that we are talking about, for example, somebody goes and buys two toothbrushes and one toothpaste. Obviously, that's one of the tuple in, let's say, from Woolworth. Then that would be one of the tuple or one of the record in Woolworth transaction data, right? And you will get a receipt. That's a printed receipt, and it contains a structure that these are the items that are purchased. This is the dollar value that is spent, and this is the total bill. Okay. If you talk about Woolworth transactions that are done at the, let's say, town hall outlet for the whole month of June, if you try to extract them and try to count how many toothbrushes were sold, that's again hard to dig down. Okay, because the number of transactions that are done on in 1 hour, that exceeds. Okay, then if you look at all of different outlets, how many toothbrushes are sold, then that would be again a different task. Okay. So what happens is that after 2 weeks or after, uh, whenever you purchase some item, they tell you there's a return policy. It's a 2 weeks policy, it's a 4 weeks policy. Basically, they are keeping the data set at that particular point of sale for those 2 weeks, 4 weeks, or 1 week, or 7 days. Okay. So if they are removing the data set from there, you won't be able to come back and return the item. Although the person who was standing up over there at point of sale, they fully recognize you. They know that you did this shopping. They won't be able to assist you at all, and they cannot perform the reverse operation, the return or change exchange, because they don't have access to the data set. Okay, so once they lose the access to data set, what happens is that that structured data is converted in a form that is semi-structured or cozy structured. So it removes the date aspect. It removes when was it exactly done. It just keeps that information, transactions done in July, or July part 1, 2, 3, 4. Part 1 is week 1, or part 2 is week 2. We don't know what are the dates for July. Okay, so they convert it in a form that can be packed up in a partially unstructured way. Okay, so that's another description of structured versus unstructured data set. How long the user remains in site? How many minutes do you spend on a site? Is this a structured data or unstructured? Since it is quantifiable, so it is structured. Okay, so friends list is structured. Status, you can say yes. Media uploads or downloads, we don't know. This could be unstructured. Okay, calls, billing preferences, special instructions. Every 5 minutes Google gets petabytes of information through its server logs. Okay, just now, so how many of you searched for structured and unstructured data set? So not only from here, from different locations, the number of those search strings, they are getting a lot. So they get like around petabytes of information. Same is also true for YouTube, Twitter, Facebook, Yahoo, for all the social media aspects. So this is from 2021. We are in 2026 now. So you can well imagine it's even way higher. And why are we getting those big data easily stored or easily being processed? Why is this data expansion? You can see somewhere around 2010 to 2020, in the 10 in this decade, it has more than doubled. Okay, what is the reason? The reason is the technology that is used to store the data. So we are enrolling students at KOI, okay, in different courses for MBA. So we are supposed to keep track of your student enrollment, right? So one way or the other, we need to store that data somewhere, right? So instead of, once the students they graduate, we get the alumni data. So instead of just keeping that data or throwing it away into the bin, we need to keep that data, because once you graduate as a alumni, you are still able to access how many units did I study, which courses, and different institutions, they can double check whether you are a graduate from here or not. Okay, so we have to keep that data safe. Since we are getting that data because we have to keep it safe for our students, then why not analyze that data as well? And the technology that can be used to store the data, the hardware chips that were used, they are also getting cheaper. Okay, so that's why instead of relying on, and sometimes you can purchase data storage from cloud as well, okay, based on minimal cost. So that was one of the reasons why this expansion of the data to, you can see, brontotype, brontobyte, sorry, and yottabyte, and these large numbers, they are coming along because the technology to store that data is easily available, and the reasons that we should not delete that data are getting higher. Okay, we do require historical data for past 10, 15, 30 years. And even some of the universities, they are keeping that data set for 100-year plus. Okay, that's the normal lifespan of an individual, but they're still keeping those alumni records since technology is supporting that. Plus, yeah, so based on these enablers, the storage capabilities, the processing powers, and the availability of data around, these are the enablers that help us to create those big data sets. And whom does big data matters the most? Obviously, organizations, internet service providers, marketing, healthcare. Okay, how important it would be that what is causing those heart attack rates to go higher? For in one of the study, I was just looking at the mental health plus heart health in different genders. Why are males more prone to heart attacks? So they explored those features. So and at limited age, while females they are somehow managing to survive more. So that was an interesting study, and it could be, and how did it happen? Because they had data for past couple of years. So they did not just make a statement because we don't like women, or we have grudge, not based on gender thing. Rather, data told us these answers. Okay, so you're relying on data. So governments, they require that, research, community, media, customer services. Now, the technologies for big data, there are plenty. You are going to rely on the Tableau tool for the purpose of analysis. Then we have a description of Apache Hadoop, but it requires a bit of programming skills. So if you are really interested, you can go for those certifications as well, or trainings for SQL, structured query language, using Apache Spark. It is not difficult, but yes, it does require background from IT. So we are going to rely on that of Tableau plus RapidMiner. That is not even, I think, listed here because of the fact that the slides were designed way earlier. Okay, any questions? So with this, we complete your big data topic. And the reason we are studying this is because you have to select one of the big data files for the purpose of your assignment. Okay, so in today's tutorial, I will talk about your accounts for Kaggle. Okay, so if you go to Kaggle.com, I will put it in the chat window for online students as well. I know you are all looking for a quick break. We will definitely, yeah. So this is Kaggle thing. So once you come back from the break, we will register the account here. Since I already have Kaggle account from KOI email, so I will go back to the same browser where I've signed in with KOI email, and I will put Kaggle.com here. I will try to sign in with my Google, and you can see that I have signed in. So everyone should be able to sign in to your Kaggle accounts today. That's one of the tasks that must be done during the tutorial time. Okay, so before I start your tutorial, I will let you take a quick break. Okay, 4:15, I will come back in 10 minutes. Okay, so you take your break before leaving, or I'll definitely answer once we come back. Let me stop the recording here.